So, hey everyone, I'm Hiro, and today I'm gonna discuss my physics project, and my topic is, does the speed of the sound keep changing in different temperature? You know, while I was thinking about the question, it comes from very nature, atmosphere. You know, a few months in California, fires keep burning and it never stop. So at that time I was thinking about where the speed of the sound change in different temperature. Like the fire is so strong, people might be feel different. So here we go. To understand the question, we need to figure out some basic background information. So, as you might know, the speed of sound is 340 meters per second when the in 20 degrees. And then this is the speed of the sound. And my question, what am I asking about? Will the speed of the sound keep 340 meters per second in different temperature? Yeah, so my question becomes like this. Now we just need to know, or we can just say prove, where the speed keep constant like 340 in different temperatures. And here's how my experiment works. So the formula I was gonna use during the whole experiment is velocity equal the distance we call x, and time we call t. We just need to figure out the time and the distance, that we can find the velocity. And it's pretty simple, I'm sure. But now is how the experiment works. By my own experience, we can just take very simple, make it simple like this. This is the ground, and I think it's better like far enough, and it's a very empty ground, which can dissolve the background noise. You know, sometimes other words can also affect the experiment. So it's like a very huge ground. And here I'm gonna have people. Oh yeah, and this means in later experiment you're gonna see. And I have I'm gonna make noise in here, and from here to here. Here's my camera. Yeah, is that what it's recording now? There's a distance, which is x. And as I want to make the data be more accurate, I want the x as big as it can. So I can make it as big as I can, as I said. And here, when I make a noise, there's a wave, you know, sound is like a wave, and it's gonna be received by the camera. But we all know the velocity, the sound of the wave the sound has a velocity, which means it has that time. It needs time to cross here. So we got another unit, which is delta t. And now and how we can find delta t? Some people may ask, just say, well, we can just use our mind to figure out the time, but it is the very old way. It works, but it's not accurate enough, because for people, we have very special, because when an ear get the sound, it needs to transform to the mind, and it needs to take a little bit of time, which is called other delta t1. And delta t1 usually becomes 0.1 seconds. So as you can see, if we put the speed of the sound, which is in 20 degrees, 340 meters, we can find it's 34 meters. And that is the delta x. The delta x is too big that we're going to get a very different and not correct answer. So to avoid it, we choose the camera. Camera here. And for the camera, why we choose camera? Because camera doesn't need time to realize, which means when the sound come here, it will just record it as it come. Same time, it will not have difference. Also, the camera also has I don't know what it's called, but I think it's called FPS, which means they took video in x times in 1 second, and the sound we can, by using some software and to analyze the video, we can find out the exact time when the camera hit a sound, right? And you may also ask why it works. Well, the thing is, we know our eyes can receive anything, can receive the light we can see. But think about the speed of the sound, speed of the light. I think we already learned it is 3 multiplied 10 to the 8 times meter per second. And here is the word sound. It is 3 multiplied 4. You can see the light is so fast that it almost doesn't affect the whole experiment. So we just depend on the light the camera took, the images the video took, and the sound when the camera got. They have a different time, and the different time actually is what we call delta t. Maybe it's hard to understand, but we just make it easy. So think about nature, or very natural atmosphere. We always saw the lightning. We always saw the light first, and then after few seconds we hear the sound. What is that? Why did that happen? Because the light is so fast that we can see it first, but the sound needs more time. More time to transform from the sound the place where the sound happened into our ear. You see, yeah. So that's how it works. And also to find out is the different temperature it is hard to find temperature, to determine temperature in a very small area, but the good thing is today is a very good day, it's a sunny day, so the sounds keep the ground. This sound, and we know it is a sunny day, so the sounds keep spread the heat to the earth, which means the temperature is keep rising during our time until the sun goes. So which means in different time when the sun is still here, it's still alive, still we can see temperature is keep rising. So we just need to find a different time of the day that we can get a different temperature. And in a different temperature, a different time, we measure the speed of the sound. Then we can get different data of the sound, the speed of the sound. Okay? So now we're gonna go to make the experiment.